Now here we will discuss the data transfer instructions and arithmetic instruction. In the last class, we have seen the classifications of instruction based on the functionality. Now we will see the instruction formats of data transfer instructions and also arithmetic. Now here this is the first instruction, move RD comma RS. This is the format for the move instruction. Now here you can use the two register. One is the destination. D indicates the destination register and S indicates the source register. Now here you can see the example. Move B comma C means what? Here this is a source register. Source register content you are moving into the destination register. Now here the B. So C content you are moving into the B register. So whenever we need to transfer the data between register to register, that time we have to use this instruction. Now coming to the next one, move RD comma M means what? From the memory location, we are moving into the data. Now here you can see the move B comma M. So from the memory location, we are moving into the content to the B. So M is nothing but what? HL pair is pointing to one location. In this location, whatever the data is there, that we are moving into the B. Here instead of writing the HL, here we mention the HL pair by using the M. Wherever M comes, then that is nothing but what? HL pair pointing to which location, that location content is moved. Now coming to the next one. Now here move comma RS means what? So source content we are moving into the memory location. Now if HL pair is pointing to 6500, if we use this instruction means what? C register content we are moving into this location. So whatever the data is there in the C, that we moved into this location. So this is about the move instruction. Next coming to the move immediate. Now if you specify the data within the instruction, that time you have to use the move immediate. Example, move immediate A comma 57 means what? 57, the operand you are moving into the accumulator. Now move immediate M comma 57 means what? You are moving this 57 into the memory location. If HL pair is pointing to 6500, in this location you are moving the 57H. Now address, now 65, every address holds only the 8-bit data. Now here how to write the 57? 7 I can write it as a 011 binary value. If I'm writing, this is a hexa value I specified. For this hexadecimal equivalent binary value is what? 011. Similarly for 5, what is the equivalent binary value? 0101. If you see, this is the 8-bit data. So in every location, we can store only the 8-bit data. Now this 8-bit data, we are moving into this location, and this location is pointed by the HL pair. So that HL pair we are mentioning by using the M. Wherever M comes, you have to keep in mind that it is indicating the HL pair. Now next one is what? LXI register pair comma 16 bit means what? Similar. Now just now I have said that HL pair is pointing to one location, I said. Now how it will point? Now we have to use this instruction. LXI H comma some location if you specify. Now if I write LXI H comma 6500 means what? HL. So we are moving this register, this value into the HL. So in a L is a lower order register. In this lower order address is moved, and H is a higher order register, higher order address is moved. Now this 16 bit I can divide it into two parts. This is the lower order 8 bits, this is the higher order 8 bits. Lower order 8 bits will be moved into the L. Now here I didn't specify the L, but if I am specifying X means what? Register pair. If I have taken the X means automatically what? It is a HL pair only. So whenever pair is need to be specified, that time no need to specify the two register. So by specifying H, it understands that it is a HL pair. So this is how to point the one location by using the HL pair. This is LXI H. Now LDA address location means what? Loading the accumulator with this address location. Now in this address location, if some data is there, that data we are moving into the accumulator. So if this is accumulator, this data we are moving into the accumulator. This is the LDA, load accumulator. Now LDA X means what? Loading the accumulator with the register pair. If we are specifying B means what? BC register pair. Whatever the BC is pointing in that location, whatever the data is there, that data we are moving into the accumulator. Now, if the BC is pointing to some 7,000, so in this location, whatever the data is there, that data we are moving into the accumulator. Now, similarly, if you take D, then DE pair. Now, DE is pointing to which location? That location content we are moving into the accumulator. Now, LHLD means what? Now, LXI is what? In this HL pair, we have moved the 6500. Now, LHLD means what? Now, in this location, 6500, whatever the data is, for example, 6500, 10H is there, and 6501, 12H is there. Now, this content we are moving into, now this is moved into the L register, and this will be moved into the H register. Lower order address content will be moved into the lower order register, and higher order address content will be moved into the higher order address. Now, instead of moving this address, in this address, whatever the data is there, that data we are moving into the HL register. So this is the difference between LXI and LHLD. LXI will point, now whatever the LXI, after that, if you are specifying any location, means that location you are moving into the HL. So L moves the 00 will be moved into the L, and 65 will be moved into the HL. Now LHLD means what? Not this address is moved into the HL pair. In this address, whatever the data is there, that data will be moved into the L, and consecutive memory location. Automatically it will increment, and consecutive memory location. Next location, whatever the data is there, that data will be moved into the H register. This is about the LHLD. Now STA, store accumulator, means what? Accumulator content we are storing into this memory location. So in 500, if we wanted to store the accumulator value, if accumulator is holding the 12H, now if that value we wanted to move into the memory location, then we have to use this, and after using that, 12H will be loaded into this location. Now STAX, register pair. Now, content of the accumulator are occupied into the memory location specified by the content of the register pair. Now, BC is pointing to any one location. Now, for example, 6500, it is pointing to 6500. Now, in whatever the data is there in the accumulator, that will be loaded into this location. This is the indirect form. Now exchange. Now here only you have to say XCHD. So with this what? HL pair will be exchanged with the DE register pair. Now whatever the data is there in the DE will be exchanged with the HL. You don't need to specify any register or anything here. Just you have to say XCHD. Default it will understand that it has to exchange these two register pair. Now we will try to see the few arithmetic operations. Now add R means what? Add register. If you specify like this register will be added with the accumulator, and result will be stored again in the accumulator. Now if we wanted to add the memory location, now M means what? HL is pointing to one location. In this location, whatever the data is there, directly if we wanted to add that data with the accumulator, then we have to use this add M. Now add carry. If we need to consider the carry, so at that time we have to use the add carry. Now add carry B means what? B content we are adding with the accumulator and also considering the carry. If carry is set, then carry bit also added with this. Now similarly like that memory content will be added with the accumulator along with the carry. Now add immediate 8-bit data means what? Here, whatever the data you are specifying, that data will be added with the accumulator content. Whatever the data is there in the accumulator, that will be added with the data which are specified within the instruction, and result will be stored in the accumulator. Similarly, add carry with the immediate. So along with this data, it will added with the accumulator along with the carry. So dad means whatever the register pair you are specifying. If you are specifying B means what? BC register pair will be added with the HL. Now whatever the data in the HL will be added with the DC pair. So this instruction we use for the 16-bit addition. And if you specify D here, then the DE pair will be added with the HL pair. Similarly, subtraction. Now instead of addition, subtraction is there. So sub R means what? Now whatever the register value you specify, that will be subtracted from the A, and result will be stored again in the A. And here here two's complement addition will takes place when it is used, when the subtraction is used. And similarly, memory location also same, like in the addition how I have explained, same. So memory location content also you can, now here you can consider the borrow. This is for the immediate data. Now whatever the data you are giving, this data you can subtract from the accumulator content. With borrow, immediate data you are considering the borrow also. Now increment R means what? Now here if you say increment B means, so whatever the data is there in the B, that will be incremented by one value. Now increment M means what? In the memory location, HL pair is pointing to one location. In this location, whatever the data is there, that data will be incremented by 1. Now increment X means what? Pair, registered pair. Now here, X means what? XL is pointing to one location. That location value will be incremented. Now this is for the 16-bit. This is for the registered pair. Here, if you are using these H will be incremented. If you say B will be, BC will be incremented. DE will be incremented. Now, similarly, decrement. So, instead of increment, decrement will take place. For the 8-bit, it is a DCR. For the 16-bit, it is a DCX. Now, these are the few arithmetic and data transfer instruction. In the next lecture, I will explain the logical and control instructions.